Huh? Hello children, your Vanashri ma'am is back with electrolysis part 2. Okay, now in this part 2 we will be learning the most important part of this chapter that is usually asked in the exam. That is very important from the point of view of exams. Okay, now in the exam from this chapter mainly that is asked are the chemical reactions of electrolysis of certain compounds, the product that is liberated in the anode at the cathode, and the reactions. Okay, so let us do one by one. Okay, so first let us do electrolysis of sodium chloride. Electrolysis of sodium chloride. Okay, now in the electrolysis of sodium chloride, the electrolyte that we use, okay, they will ask in the electrolysis of sodium chloride, name the following. So electrolyte used. Electrolyte used is naturally sodium chloride, but in molten state or in aqueous solution state. Okay. Okay. So electrolyte used sodium chloride. Sodium chloride in aqueous solution. This is more easy than molten state. Okay. Then they will say write the chemical equations. So equations. The equations are NaCl reversible, Na plus Cl minus. Okay. So then they may ask name the cations. Cations and anions. Okay. Cations are Na plus and H plus. H plus comes from the aqueous solution, that is water part. Okay. And the anions. Anions are Cl minus and OH minus. Cl minus is from sodium chloride and OH minus is from water. Okay. Then now reaction at cathode. Reaction at cathode is the hydrogen ions, that is H plus ion, accept an electron and becomes hydrogen atom, neutral hydrogen atom, and two hydrogen atoms combine and hydrogen gas is released at the cathode. Okay, so this is the preferentially it is released. Okay, and reaction at the anode. Reaction at the anode. Now the chloride ion, that is Cl minus ion, loses one electron and forms neutral chlorine atom, and two chlorine atoms combine forming chlorine gas. Okay, so this is how the questions are asked and this is how you have to answer. Okay, so they may ask product at anode. What is the product that is liberated at anode? Chlorine gas. And product at cathode, hydrogen gas. Okay, these two are the products that are released in the electrolysis of sodium chloride. Okay, children. Now the second one. Second one is very important. Electrolysis of copper sulfate. Now in the electrolysis of copper sulfate, so what is the electrolyte used? Electrolyte used is dilute copper sulfate solution. Okay, now the electrolytic equation. Electrolytic equation is CuSO4 reversible Cu2 plus SO4 2 minus. Okay, and the aqueous solution, that is water, breaks up into H plus OH minus. Okay, same thing in sodium chloride also have I written equation. No, sorry, you have to mention along with this. Here also you have to write. Here also you have to write H2O reversible H plus OH minus. Okay. Okay. So these two are the electrolytic reactions. Then cations, or they say ions migrating to cathode. So their cathode is negatively charged, so Cu2 plus and H plus ions, and anions or ions migrating to anode, or at the anode you will have SO4 2 minus and OH minus. Okay, then reaction at the cathode. Reaction at cathode. Reaction at cathode will be Cu2 plus 2E minus gives Cu. Okay, so at the cathode Cu2 plus accepts 2 electrons and becomes Cu atoms, that is copper atoms. Then reaction at the anode, 4 hydroxyl ions lose 4 electrons, 1 each, and form 4 OH. Now 2 OH plus 2 OH, that is those 4 OH, gives 2 H2O plus O2 gas is released. Okay, so in the electrolysis of copper sulfate, What is the product at anode? Product at anode is oxygen gas. Product at cathode is copper metal. Okay, so this is how they will ask. Okay, clear? Then the next one is electrolysis of lead bromide. Lead bromide, electrolysis of lead bromide. So, what is the electrolyte? Electrolyte is molten lead bromide. Okay. Then electrolytic equations are PbBr2 gives Pb plus and Br2. Pb 2 plus, and it will not be it gives, but it will be reversible. Okay, Pb 2 plus and 2 Br minus. Okay, Pb 2 plus and 2 Br minus. Okay. So at cathode, what happens? Pb2 plus accepts 2 electrons, forms Pb metal, and at anode the bromide ions lose 1 electron each and forms bromine atoms. Then 2 bromine atoms form bromine gas. Okay, so what are the products? Product at anode is reddish brown, fumes of bromine gas. That is Br2. Okay, and product at cathode is grayish white metal, lead metal is formed at cathode. Okay, Now the next one is again very important, electrolysis of acidified water. Electrolysis of acidified water. Okay. Now electrolysis of acidified water using platinum electrodes. Now here the electrodes that are used are platinum. Okay. So electrolysis of acidified water, electrolysis of acidified water using platinum, electrodes. Okay. So that is the diagram for electrolysis of water using platinum electrodes. Now this acidified water means the water is acidified with few drops or a few small amount of dilute sulfuric acid is added so that the water starts conducting electricity. Otherwise pure water is a non-conductor of electricity. And dilute sulfuric acid is only preferred because it is non-volatile. If you use nitric acid, dilute nitric acid or hydrochloric acid are both volatile acids. That is why they are not preferred. Okay. So electrolyte acidified water, acidified with dilute sulfuric acid. Okay. So now the electrolytic equations water, that is H2O reversible, H plus and OH minus ions. Okay. And the dilute sulfuric acid which is present in the water, it also ionizes, forming 2H plus plus SO4 2 minus. Okay. Now these are the electrolytic equations. Now cations or ions present are cations. Cations are H plus ions and anions are OH minus and a sulfate ion, that is SO4 2 minus. Okay. So reaction at the cathode, is H plus plus E minus gives hydrogen atom. Now the two hydrogen atoms combine forming hydrogen gas. Okay. Then reaction at the anode, will be OH minus will lose one electron and will form OH, and 2OH 2OH will 2OH radicals 2OH will combine forming water and oxygen. Now two oxygen atoms combine forming oxygen gas. So now product at cathode is hydrogen gas and product at anode is oxygen gas. So product at cathode at cathode is hydrogen gas, right? So hydrogen gas. Product at anode is oxygen gas. Okay. Now you have learned the electrolysis of copper sulfate solution. Okay. Now it has two cases. Electrolysis of copper sulfate solution using platinum anode and copper or platinum cathode. Okay. Now please pay attention. Here the electrolysis of copper sulfate we will consider using platinum anode and platinum cathode or copper cathode. Okay, so let us study this in detail. Electrolysis of copper sulfate using, let us say first, platinum electrodes. See, electrolysis of copper sulfate using platinum electrodes or copper cathode. That means what? Either both anode and cathode, either both are platinum, that is PT, or anode is platinum and cathode is copper. Okay. Now in this case, what happens is the copper sulfate, as usual, CuSO4 dissociates forming Cu2 plus SO4 2 minus, and the water dissociates forming H plus and OH minus. Now reaction at the cathode is the copper ions are below hydrogen ions in the activity series. So copper ions discharge in preference to hydrogen ions and therefore neutral copper atoms are formed. Okay. So Cu2 plus 2E, that is they accept 2 electrons and form neutral copper atoms. Now the copper atoms deposit themselves on the cathode, okay, or they get deposited at the platinum, or if it is a copper cathode, it gets deposited on the copper cathode. Now reaction at the anode. Reaction at the anode, the sulfate ions and the OH minus ions are both migrate to the anode, but the OH ions being lower to the in the electrochemical series as compared to sulfate ions discharge to form neutral OH radical. Then the neutral OH radicals reunite to form water and oxygen. Okay, so 4 OH minus lose 4 electrons, 1 electron each, and forms neutral 4 OH. Then these 4 OH combine, forming 2 molecules of water and oxygen gas. So product at the anode is oxygen and product at the cathode is copper. So product at anode is oxygen gas, product at cathode is reddish brown copper metal. Now here there is an observation. When all the copper ions they migrate and either get deposited as copper metal or get deposited on the copper cathode, then the copper sulfate solution loses its blue color and becomes colorless, because the color of the copper, blue color of the copper sulfate solution is because of the copper ions. So when all the copper ions migrate to cathode, the blue copper sulfate solution loses its blue color. Why? Because the blue color is due to the presence of copper ions, Cu2 plus ions. So when all the copper ions migrate to the cathode, the solution becomes colorless. Okay, so that indicating that all copper ions are finished. Okay, so this is an important observation which often they are asked. Okay, now if both the electrodes used are copper, then what will happen? So now we will do electrolysis of aqueous copper sulfate using copper electrodes. In the earlier one we have used either both electrodes as platinum, or we have used the anode as platinum and cathode as copper. In that case we have seen how it happened. Now we are doing electrolysis of aqueous copper sulfate using copper electrode, that is both anode and cathode both are copper rods. Okay, in that case this electrolytic equation CuSO4 reversible Cu2 plus SO4 2 minus. Okay, then the water H2O dissociates, forming H plus OH minus. Okay, so cations are Cu2 plus and H plus. Anions are SO4 2 minus and H minus. Okay, now reaction at anode. Copper loses 2 electrons and forms Cu2 plus ions. and SO4 2 minus and OH minus ions migrate to anode, but neither of them are discharged due to the nature of the anode. Copper loses electrons more easily than sulfate and OH minus ions because copper anode itself ionizes to give copper. Here we are using copper as the anode. So copper anode itself starts discharging or losing copper Cu2 plus ions. Okay, so reaction at cathode. Again, Cu2 plus accepts 2 electrons and forms neutral copper. Okay, and copper Cu2 plus and H plus ions both migrate to cathode, but Cu2 plus ions are discharged as neutral copper atoms by accepting electrons. Okay, so product at cathode is pink or reddish brown copper. Okay, so now here what happens? The electrolyte of aqueous copper sulfate may be acidified with traces of dilute sulfuric acid. You have to slightly add dilute sulfuric acid. This enhances the conductivity of the electrolyte. Okay. Now, the blue color of the aqueous copper sulfate solution remains unchanged during its electrolysis with copper electrodes. Why? Because the copper ions are always present in the electrolyte. That is why. So in this, the observation is the blue color of the electrolyte remains unchanged when we use copper electrodes. Okay. Okay. Now children, we will be doing another very important topic, that is applications of electrolysis. So there are three applications. One is electroplating with metals, electroplating. The other one is electrorefining, and the last one is extraction of metals. These are the three applications of electrolysis. Now, electroplating. Now, what is this electroplating? Now, the inferior metals are often coated with superior metals. Like, for example, iron. Iron is an inferior metal because iron articles get rusted. Even iron poles get rusted. So, they are usually electroplated with superior metal like nickel. So, it prevents the rusting. So, not only that, even sometimes the copper articles or iron articles are electroplated with superior metals like silver, gold, platinum, etc. using electroplating. So, this electroplating is very useful industrially. Okay. Now, so electroplating is used for decorative purposes also. For example, brass objects are frequently plated with silver to give them shining appearance and beauty of a silver article. Then also to protect from rusting and corrosion. Like iron tools and instruments, as I told you, are often electroplated with nickel or chromium or zinc to protect against rusting. Okay. So now very important conditions for electroplating. Okay. Conditions for electroplating. Conditions for electroplating. The article to be electroplated is always placed at the cathode. So the article to be electroplated. So usually this is a very often asked question. You are asked to even draw the diagram and show that a spoon is to be electroplated. Draw the diagram for the setup, they say. So the article to be electroplated is always placed at the cathode. For example, here a spoon, a metal spoon is being electroplated with, say, copper. So in that case, the spoon is the cathode. Why? The spoon is connected to the negative terminal of the battery. That is why it becomes cathode. Okay. The metal to be plated on the article is always made the anode. So the second condition, this is the first condition. The article to be electroplated is always placed at the cathode. Second condition is the metal with which the article is to be coated is kept at the anode. Now sometimes it may be coated with copper, then it will be anode will be copper rod. If it has to be coated with silver, then the anode has to be silver rod. Or if it has to be coated with gold, then the anode must be gold rod. If the spoon has to be coated with nickel, then the rod should be nickel, and so on and so forth. Okay. Then third condition is the electrolyte must contain the ions of the metal which is to be plated. Which is to be plated on the article. Okay, so the electrolyte should be a compound of that metal. Okay. Okay, so these are the main conditions that are required for electroplating. Now, electroplating an article with silver. In that case, the electrolyte has to be the electrolyte which is generally used is sodium argentocyanide. Sodium argentocyanide. The formula is Na AgCN twice. This is the formula, NaAgCN twice. Okay. Now, when this compound dissociates, so NaAg sodium argentocyanide, NaAgCN twice. When it dissociates, it forms Na plus Ag plus 2 Cn minus, and the water in the solution forms H plus and OH minus ions. Okay, so the cathode is the article to be electroplated. Anode is a rod or plate of pure silver. Okay, so at cathode, Ag plus accepts electrons and forms neutral silver. And at the anode, the silver from the anode itself loses electrons and forms Ag plus ions, which go into the electrolyte. The negative ions, that is Cn minus, that is cyanide ions, and OH minus ions, migrate to the anode, but none of them are discharged. Instead, the atoms of anode, that is silver, lose electrons and pass into the solution as silver ions due to the nature of the anode. Silver ions are attracted to the brass spoon, which is the cathode, which is negatively charged. Hence, the article, which is the cathode, gets coated with the silver metal. Okay. Okay, now electroplating with nickel. Electroplating with nickel. Okay, so in this case, the electrolyte to be used is nickel sulfate, that is NiSO4. So nickel sulfate, NiSO4, dissociates forming Ni2 plus ions and SO4 2 minus. And the water, again as usual, water in the aqueous solution dissociates H plus and OH minus ions. Now cathode will be again the article to be coated, article to be electroplated, and anode will be block of pure nickel. Okay, so reaction at cathode, Ni2 plus 2 electrons gives nickel metal which gets deposited. Okay, and reaction at anode, the nickel ions, they lose 2 electrons and forms nickel ions which move into the electrolyte. Okay, is that clear, children? Now, electrolytic refining. In metallurgy. Now, for example, in metallurgy, when we extract the metals are often impure. The metal that is extracted by in the metallurgical process is impure. So, they have to be refined, they have to be purified. So, that purification is done by electrolysis, that is called electrolytic refining. Now, in this, the electrolyte is always the salt of the metal which has to be purified. So, for example, if we want to refine copper, so electrolyte will be a salt of metal copper, so that will be, say, copper sulfate. Copper sulfate solution acidified with dilute sulfuric acid. With dilute sulfuric acid. Okay, and cathode will be the thin strip of pure copper. Thin strip of pure copper, because on this the copper ions from the impure metal come and get deposited. So, thin strip of pure copper is taken, and at the end of the electrolysis, this thin strip of copper becomes thick with the deposition of more and more copper ions from the anode, and the anode is the impure copper that needs to be purified. Okay, so copper ions from this impure copper migrate to the cathode and get deposited on the thin strip of the pure copper. So the copper cathode, which in the beginning is a thin sheet, becomes thicker and thicker during the process of electrolysis. Okay, so again, at cathode, Cu2 plus accepts 2 electrons and forms neutral copper atoms, and at anode copper atoms lose 2 electrons and again form Cu2 plus ions. Now these Cu2 plus ions migrate to the cathode, and the copper ions go and get deposited into the thin sheet of the pure copper sheet that we have taken, and in this way all the copper ions from the impure copper go and get deposited on the thin sheet of the copper cathode, and that thin sheet of copper cathode becomes thicker and thicker by the end of the electrolytic reaction. In this way, metals are refined using electrolysis. And the other application of 5 minutes. Now, the third application of electrolysis is electrometallurgy. Electrometallurgy. Now in this electrometallurgy, we extract metals using electrolysis. So electrometallurgy is a process in which metals are extracted by electrolysis. So it is a process of extraction of metals by electrolysis. Okay, now here what happens, reactive metals usually are extracted from their halides, that is chlorides, bromides, etc. by electrolysis using inert electrodes. Cathode is usually made of iron and anode of graphite, so they are inert electrodes. Okay, so for example, potassium electrolyte will be fused potassium bromide. Okay, for example, extraction of, for example, extraction of potassium metal. So in this electrolyte is fused potassium bromide, that is KBr. So this is the electrolyte for extraction of potassium. So now reaction at the cathode, potassium bromide, that is KBr, dissociates into K plus plus Br minus ions. Now reaction at the anode, is the chloride ions, that is Cl minus ions, which have migrated to the anode, they lose one electron forming neutral Cl atoms. Then two Cl atoms combine forming chlorine gas. Okay, so this is how the metal potassium is extracted by electrolysis using potassium bromide as the electrolyte. Similarly, aluminium is obtained by electrolysis of aluminium oxide. So aluminium is obtained by the electrolysis of aluminium oxide. This you will learn in detail in metallurgy in extraction of aluminium. So here you will be learning more in detail about this, but the electrolyte is aluminium oxide Al2O3 plus we use cryolite that is Na3Al(F6) and fluorspar. Okay, why we use, we will learn in detail in metallurgy of aluminium in metallurgy chapter. Okay, now the reaction will be aluminium oxide Al2O3 reversible 2Al3 plus 3O2 minus. Then reaction at cathode is 2Al3 plus 6 electrons forms two neutral aluminum atoms, and reaction at anode 3O2 minus loses 6 electrons forming 3 neutral oxygen atoms. 3 neutral oxygen atoms combine with 3 more neutral oxygen atoms forming 3 oxygen molecules. So this is how the metallurgy of in the metallurgy of silver we use electrolysis. Okay. Thank you, children. This completes the chapter electrolysis. Go through it. If you have any doubts, we will clarify in our doubt session. Thank you for watching. Take care. God bless you.